Hi everyone, in this video I will be discussing another integration technique for integral calculus, which is what we call as integration by parts. So before, we have already discussed the u substitution, wherein we integrate by letting u as a certain value in our expression. Now this time we will be having integration by parts. So this integration method is useful if there are expressions, or we will be integrating expressions that are expressed as the product of two functions. So in your differential calculus, if you had the product rule for differentiation, in integral calculus we have integration by parts, which is the product rule for integration. We have this formula: the integral of u dv is equal to uv minus the integral of v du. And actually this formula is derived from the formula of the product rule for differentiation. Now, in assigning the values of u and dv later on, when we will be letting u and dv be certain functions or values, we use the acronym LIATE. So this will be our basis in choosing as to what our u and dv will be. So L stands for logarithmic, I stands for inverse trigonometric, A stands for algebraic, T for trigonometric, and E for exponential. Now, actually these are all more or less familiar to you, since I have discussed integration of these following functions. We already had integration of logarithmic, trigonometric, exponential functions, and also the basic integration rules for algebraic functions. So more or less you will be able to recall as to how to integrate and apply what you have learned for these certain functions. Now let's have this example. We have the integral of x sine x dx. Now if you take a look at this expression, x, that is an algebraic function, sine x, that is a trigonometric function. Now if we check with our acronym LIATE or LIATE, A comes first before T. So A, that will be our u, T will be our dv. So going back to our formula, that's the integral of u dv is equal to uv minus the integral of v du. So we let u be x, dv will be our sine x dx. So you already have the value of u and dv, but we still need to get the value of v and the value of du. So therefore, in order to get du, we need to look for the derivative of u. So the derivative of u, or the derivative of x, is simply dx. In order to get v, we need to get the integral of dv. So that's the integral of sine x dx. And as you all know, based on the previous discussions, the integral of sine x dx is simply negative cosine x. Substituting to our formula, that's the integral of, That's the integral of x sine x dx is equal to, so that's uv, so that's x times negative cosine x minus the integral of v, that's negative cosine x du is simply dx. So simplifying, that is negative x cosine x, then it's negative and negative, so therefore that will be positive. And again, we have a formula for this one. The integral of cosine x is simply sine x. And since we're done, again, always do not forget the constant of integration, c. So the integral of x sine x dx using integration by parts is negative x cosine x plus sine x plus c. For our next example, we have the integral of ln x dx. So this is very easy. Ln x, that is logarithmic, right? Logarithmic. And dx, if there, we know that there is 1, so that is algebraic. And based on LIATE, LIATE, our acronym, so logarithmic comes first before algebraic. So ln x will be our u, then dx will be our dv. So let u be ln x, then dv is simply dx. Then look for the derivative of du. The derivative of u. So recall that the derivative of a natural logarithmic function is simply 1 over x dx, or simply dx over x. Now for this one, for dx, the integral of dx is simply x. Now recalling the formula for integration by parts, that's the integral of u dv is equal to uv minus the integral of v du. So substituting the integral of u dv, this one, that's the integral of ln x dx is equal to uv, so that's ln x times x minus the integral of v du, so that's x times dx over x. So arranging or simplifying, that's x ln x minus, we can cancel this one, cancel that one, so we'll be left with the integral of dx. Further simplifying, that's x ln x minus the integral of dx is simply x. Then don't forget our constant of integration, c. Let's have this next example, the integral of x squared e raised to 3x dx. So x, that's algebraic, e to the power of 3x, or e raised to 3x, is exponential. And going back to LIATE, so algebraic comes first, so that will be our u, exponential follows, so that will be our dv. So let u be equal to x squared, dv is equal to e raised to 3x. Now getting the derivative of u or x squared is 2x dx. Then the integral of this one, so for this we do not have a direct formula, so we need first to use substitution. So that's the integral of dv, or simply the integral of e to the power of 3 to the power of 3x dx. So if we let u be equal to 3x, I'm sorry, we already have u, so let's use another variable. So let's have w. If we let w be equal to 3x, dw is 3 dx. But since we only have dx here, as what I have taught you before, let me just erase that, e3x, we can actually put 3 here, but to offset we can put 1/3 here. So therefore the integral, that's 1/3 integral of e to the power of w, since 3x is w, 3 dx, that's dw. That's 1/3, and the integral of this one, as we already know, we already have a formula for this one, that is simply EW, or e to the power of w. Then going back, substituting, that's 1/3 e to the power of 3x, since w is 3x. So let's erase this one. Therefore v is 1/3 e to the power of 3x. Now formula for integration by parts, that is u dv is equal to uv minus integral of v du. So substituting, that's the integral of x squared e to the power of 3x dx is equal to u is x squared times v is 1/3 e to the power of 3x minus the integral of v, that's 1/3 e to the power of 3x, then du times 2x dx. So simplifying, that is 1/3, let's write x first, x squared e to the power of 3x minus, we can multiply 1/3 and 2, we can bring that outside of the integral symbol, that's 2/3 integral of, let's put x first, x e to the power of 3x dx. Now in here we still have the product of two functions, an algebraic and an exponential. So in this case we still need to do another round of integration by parts. So x is algebraic, e to the power of 3x is exponential. So algebraic comes first before exponential. So we let u bx, then du is simply dx, dv is e to the power of 3x dx. And earlier we have already solved for this one, the integral of e to the power of 3x dx. So let's not solve for that once again since we already know the value. So that's 1/3 e to the power of 3x. So going back to here, that's 1/3 x squared e to the power of 3x minus that's 2/3 times uv, so that's x times 1/3 e to the power of 3x minus the integral of v du. So v is 1/3 e to the power of 3x, then du is simply dx. So further simplifying, that's equal to 1/3 x squared e to the power of 3x minus, we can multiply this one, that's 2/9 x e to the power of 3x. So negative, that will be positive. That's correct, it's positive. Then that's 2/3 times 1/3, that's 2/9, and getting the integral of this one, that is 1/3 e to the power of 3x. So 2/3 times 1/3, 1/3, that's 2/9 times another 1/3, that is 2/27 e to the power of 3x plus. For the last example, we have the integral of e raised to x sine x dx. So e, that is an exponential function, sine x, that is a trigonometric function, and based on LIATE, our acronym, trigonometric comes first before exponential. So therefore, our u is sine x, our dv is e to the power of x, and dx. So getting the derivative of u, so as we all know, for the formula for the derivative of trigonometric functions, a derivative of sine x is cosine x dx. And for the integral of dv, the integral of e raised to x dx, that is simply e raised to x. So recalling our formula for integration by parts, that's u, integral of u dv is equal to the integral of uv minus the integral, that is simply uv minus integral of v du. So substituting, so that's the integral of e raised to x sine x dx, that's equal to uv, that is, we can actually write e raised to x first, then sine x minus the integral of v du. We can actually also write e raised to x first times cosine x dx. So simplifying, that's e raised to x sine x minus this one, since this is still a product of two functions, this is an exponential and a trigonometric. Same with the previous example, we will still be applying integration by parts for the second time. So we let u, so this is exponential, this is trigonometric, so trigonometric comes first, so u will be cosine x, then dv will be e raised to x, then dx. Then derivative of cosine x is simply negative sine x dx. Then derivative of dv is simply e raised to x. So going back, it's the integral of e raised to x sine x dx. That's equal to, copy this one, e raised to x sine x minus the integral minus, so this one uv, so that's e raised to x cosine x minus this one, the integral of v, which is e raised to x dv, that is a negative sine x dx. So if we simplify this one, that is e raised to x sine x, that's negative e raised to x cosine x, that's negative, so that will be positive the integral of e raised to x sine x dx. So as you notice, we are still left with this answer. So if we will be going further, if we'll still be integrating by parts, if we'll be applying integration by parts for the third time, for sure we'll still be arriving with this answer. So actually for this case, we can apply the addition property of equality. So we can do this one. We can move this one to the other side of the equation, since you've noticed both are the same. So that's the integral of e raised to x sine x dx. Let me check. I'm sorry, this should be negative, because that's negative, negative, and negative. So 3 negatives is negative. So if we transpose this one to the other side, that will be positive e raised to x sine x dx is equal to, what would remain on the other side are this one, e raised to x sine x minus e raised to x cosine x. Now integral, so that will be 2 integral of e raised to x sine x dx, because there are 2 of them, is equal to e raised to x sine x minus e raised to x cosine x. Dividing both sides of the equation by 2, we will have integral of e raised to x Sine x dx is equal to 1/2 e raised to x. Sine x minus 1/2 e raised to cosine x plus c. So do not forget plus